Hello everyone, my name is Vaibhav and today I am presenting my project CrowdShield AI, a multi-agent intelligent crowd safety and stampede prevention system. This project was developed as a part of Google 5 Days AI Agent Instance to Vibe Coding Capstone project. The objectives of the CrowdShield AI is to help prevent crowd-related accidents by analyzing crowd densities, assessing risks, and generating intelligent safety and recommendations, and involving a human operator before dispatching emergency alerts. So my problem statement is ProShield AI, which is a multi-agent integrated system, and I'm showing the estimate dashboard. So this is for the dashboard. Imagine a large public gathering such as concerts, festivals, sports, and events or political rallies. When crowd density increases beyond a safety limit, panic stampedes can occur within seconds. To monitor such situations manually is difficult, but often delays emergency response. To address this challenge, I developed a crowd shield, a multi-agent system that analyzes crowd conditions in real time. So how was my system architecture works. So it starts here, and let me explain the overall architecture of the system. The workflow begins when operator enters the crowd count and area of the location. The data first sent to the agent one crowd analysis. This agent calculates the crowd density using crowd count and areas and available area. And next calculate density is passed to agent two risk, which is risk assessment. In this, there are three categories: low risk, medium risk, and high risk. So, based on the identified risk level, the information is forwarded to agent 3, which is safety recommendations. This agent generates intelligent recommendations such as increasing security personnel and opening emergency exits and relating the crowd and activating the public announcements. And this recommendation sends to the agent 4, which is human in the loop approval. Instead of allowing AI to automatically send alert messages or alert notifications, the system asks human operator to receive the recommendations. If operator approves, the alert is dispatched. If the operator rejects, the event simply recorded and no emergency notification is sent. So coming to the human approval approach combinations, which combines AI automation with human judgment, making the system safer and more reliable and suitable for reliable emergency management. So coming to the demonstration. So this is the dashboard, React dashboard advanced, and let me demonstrate the application. So we will test low risk scenario. What is the low risk scenario? So I given the cloud count 2400 and the area of square meter is 1600. So analyze the crowd. So it gives low risk. So no emergency action is required here. So coming to the medium level of risk. So here I given crowd count is 10,000 and area is 2000. So here we can see the risk management level is in medium situation. So the risk level is medium situation and the observation is and no immediate alert required. Finally, the test is high test scenario. So now click reset pipeline and again give high risk scenario of 60,000 and in area of 2000 square meters. So now I click analyze and here we can see high level of risk. System calculates high crowd density and classifies the situation as a high risk. So agency generates emergency recommendations, including deploy additional security personnel and open emergency exits, redirect the crowd, activate public, notify emergency services. So this is what agent free functionalities and coming to the human approval. Before sending emergency notification, Crucial AI follows a human loop approach. The operator receives the recommendation and either can approve or no suppress the alert. Now click approve or dispatch. Once approved, the emergency alert is successfully dispatched. This prevents false alarms while ensuring the critical situations receive immediate attentions. So coming to the backend Swagger UI. So backend Swagger UI is nothing but the frontend communicates with fast API backend through REST APIs. The backend executes the complete multi-agent pipeline and returns the crowd density, risk level, and final response in JSON format. This app documentation is available through Swagger, making system easy to test and extend. So the conclusion of this is to conclude the crowd shield AI demonstrate how multi-agent can work together to improve public safety by combining crowd analysis, intelligence risk assessment, safety recommendations, and human approval. The system provides practical and scalable approach. In future, this project can be extended with CCTV integration, drone monitoring, computer vision, and Gemini and real-time emergency communication system. So thank you for watching my presentation.